Two separate circuits in a kitchen keep blowing out bulbs every couple of days. These circuits are fed with 12.3 wire, sharing the neutral. There is no access to the wiring because there is a junction box that's behind a counter, which now has tile and a marble top. Here are some possible causes and troubleshooting tips. Firstly, consider loose connections. Verify if all connections in junction boxes and that light fixtures are tight. Loose connections can create arcing and excessive heat. Secondly, consider damaged wiring. Inspect the 12.3 wire for any nicks, cuts, or other damage that could compromise its integrity. Thirdly, check for overloading. Ensure that the circuits are not overloaded by high wattage appliances or devices. Fourthly, neutral miswiring could be a problem. Check if the neutral wires are properly connected and not accidentally wired to a hot terminal. This can result in voltage imbalances and bulb failures. Fifthly, check for a ground fault. Test for any ground faults that could be causing the bulbs to blow. This can be done with a ground fault circuit interrupter or GFCI tester. Sixthly, circuit breaker sensitivity might be a problem. Verify if the circuit breakers for the affected circuits are too sensitive and tripping prematurely. Here are some troubleshooting tips to consider. Firstly, use a surge protector. Temporarily connect a surge protector to the circuits to protect the bulbs from voltage spikes. Secondly, swap the bulbs. Replace the blown bulbs with different ones to rule out faulty bulbs. Thirdly, isolate the circuits. Turn off all appliances and devices on the affected circuits and turn them on one by one to identify any potential causes of overloading. Fourthly, monitor the voltage. Use a voltmeter to measure the voltage at the light fixtures when the bulbs are on. Excessive voltage can damage bulbs. Fifthly, use a thermal camera. A thermal camera can detect any hot spots in the wiring or connections that may indicate problems. Regarding accessing the junction box safely, if the homeowner is reluctant to remove the tile and marble top, consider creating a small temporary access hole in the drywall behind the counter to gain access to the junction box. Alternatively, use an endoscope or borescope to inspect the junction box without removing the counter. Finally, it is important to note that if the troubleshooting steps do not resolve the issue, it is highly recommended to contact a qualified electrical contractor to safely access and repair the wiring. It is essential to prioritize electrical safety and avoid working on electrical systems if you are not properly trained. Here's a more detailed look at each of these potential issues and troubleshooting steps. Let's start with loose connections. Loose connections are a very common cause of electrical problems. Over time, connections can loosen due to vibration, thermal expansion and contraction, or simply poor initial installation. A loose connection creates resistance in the circuit, which generates heat. This heat can damage the wiring, the devices connected to the circuit, and even cause a fire. In the case of light bulbs, a loose connection can cause flickering, dimming, and premature burnout. To check for loose connections, you will need to turn off the power to the circuit at the circuit breaker. Then carefully inspect all the connections in the junction boxes and at the light fixtures. Make sure that all the wires are securely fastened to the terminals and that the wire connectors are tight. If you find any loose connections, tighten them properly. If the wires are damaged, you may need to replace them. Next, let's consider damaged wiring. The 12.3 wire used in the circuits may have been damaged during installation or at some point afterwards. Damage can include nicks, cuts, abrasions, or crushed insulation. Damaged wiring can create a short circuit, a ground fault, or simply reduce the current carrying capacity of the wire. Any of these conditions can cause light bulbs to blow out prematurely. To inspect the wiring, you will need to turn off the power to the circuit at the circuit breaker. Then carefully examine the visible portions of the wire for any signs of damage. Pay close attention to areas where the wire may have been bent, stapled, or come into contact with sharp objects. If you find any damaged wiring, it should be replaced by a qualified electrician. Now let's discuss overloading. An overloaded circuit is one that is drawing more current than it is designed to handle. This can happen if too many high wattage appliances or devices are connected to the circuits at the same time. When a circuit is overloaded, the wires can overheat, which can damage the insulation and cause a fire. Overloading can also cause light bulbs to burn out quickly. To determine if a circuit is overloaded, you will need to add up the wattage of all the devices connected to the circuit. The total wattage should not exceed the maximum wattage rating of the circuit. For a 15 amp circuit at 120 volts, the maximum wattage is 15 amps times 120 volts, which equals 1800 watts. For a 20 amp circuit at 120 volts, the maximum wattage is 20 amps times 120 volts, which equals 2400 watts. If the total wattage exceeds the maximum wattage rating, you will need to reduce the number of devices connected to the circuit or move some of the devices to a different circuit. Now, let's examine neutral miswiring. In a properly wired circuit, the neutral wire provides a return path for the current to flow back to the source. If the neutral wire is not properly connected, or if it is accidentally wired to a hot terminal, it can create a voltage imbalance in the circuit. This voltage imbalance can cause light bulbs to burn out prematurely and can also damage other devices connected to the circuit. To check for neutral miswiring, you will need to turn off the power to the circuit at the circuit breaker. Then carefully inspect the wiring connections at the light fixtures and in the junction boxes. Make sure that the neutral wires are properly connected to the neutral terminals and that they are not accidentally connected to any hot terminals. If you find any miswired connections, correct them immediately. Now let's look at ground faults. A ground fault occurs when a hot wire comes into contact with a grounded surface, such as a metal enclosure or a water pipe. This can happen if the insulation on the wire is damaged or if a connection comes loose. When a ground fault occurs, a large amount of current can flow through the grounding path, which can trip the circuit breaker or blow a fuse. Ground faults can also cause light bulbs to burn out prematurely. To test for ground faults, you can use a ground fault circuit interrupter tester. This device plugs into an outlet and simulates a ground fault. If the GFCI tester trips the circuit breaker, it indicates that there is a ground fault in the circuit. If you suspect a ground fault, you should contact a qualified electrician to locate and repair the fault. Now let's consider circuit breaker sensitivity. Circuit breakers are designed to protect circuits from overcurrents. If a circuit breaker is too sensitive, it may trip prematurely even when the circuit is not overloaded. This can cause light bulbs to flicker or go out unexpectedly. To determine if a circuit breaker is too sensitive, you can try replacing it with a new circuit breaker of the same rating. If the new circuit breaker trips as well, it indicates that there is likely another problem in the circuit, such as an overload or ground fault. Let's explore some of the troubleshooting tips in more detail. First, using a surge protector. A surge protector is a device that protects electrical devices from voltage spikes. Voltage spikes can be caused by lightning strikes, power surges, or even by turning on and off large appliances. These spikes can damage sensitive electronic components in light bulbs and other devices. To use a surge protector, simply plug it into an outlet and then plug the light fixture or other device into the surge protector. Surge protectors are relatively inexpensive and can provide valuable protection for your electrical devices. Next, let's think about swapping the bulbs. Sometimes light bulbs can be faulty and burn out prematurely, even if there is nothing wrong with the circuit. To rule out this possibility, try replacing the blown bulbs with different ones, preferably from a different manufacturer or of a different type. If the new bulbs burn out quickly as well, it indicates that there is likely a problem with the circuit. Then we can isolate circuits. Isolating circuits involves turning off all the appliances and devices on the affected circuits and then turning them on one by one to identify any potential causes of overloading. This can help you determine if a particular appliance or device is drawing too much current and causing the circuit to overload. To isolate the circuits, start by turning off all the circuit breakers that supply power to the affected circuits. Then turn on one circuit breaker at a time and observe the light bulbs. If the light bulbs burn brightly and do not flicker, it indicates that the circuit is not overloaded. However, if the light bulbs are dim or flicker, it indicates that the circuit is overloaded and you need to reduce the number of devices connected to the circuit. After this, we can monitor voltage. Monitoring the voltage at the light fixtures can help you determine if there is a voltage problem in the circuit. Excessive voltage can damage light bulbs and cause them to burn out prematurely. To measure the voltage, you will need a voltmeter. Turn on the light fixture and then use the voltmeter to measure the voltage at the terminals of the light bulb socket. The voltage should be close to the rated voltage of the circuit, which is typically 120 volts in North America. If the voltage is significantly higher than 120 volts, it indicates that there is a voltage problem in the circuit and you should contact a qualified electrician to investigate. Finally, using a thermal camera can be helpful. A thermal camera is a device that detects heat. It can be used to identify hot spots in the wiring or connections which may indicate problems such as loose connections, damaged wiring, or overloaded circuits. To use a thermal camera, simply point it at the wiring and connections and observe the temperature readings. Any areas that are significantly hotter than the surrounding areas may indicate a problem. If you find any hot spots, you should contact a qualified electrician to investigate and repair the problem. Remember that accessing the junction box safely is paramount. If the homeowner is reluctant to remove the tile and marble top, consider creating a small temporary access hole in the drywall behind the counter to gain access to the junction box. This will allow you to inspect the wiring and connections without damaging the countertop. Alternatively, you can use an endoscope or breast-up to inspect the junction box without removing the counter. These devices are small, flexible cameras that can be inserted into tight spaces to provide a visual inspection. It is important to emphasize that if the troubleshooting steps do not resolve the issue, it is highly recommended to contact a qualified electrical contractor to safely access and repair the wiring. Electrical work can be dangerous and should only be performed by someone who is properly trained and experienced. A qualified electrician will be able to diagnose the problem accurately and make the necessary repairs safely and effectively. Remember, electrical safety should always be the top priority. Before working on any electrical circuit, be sure to turn off the power at the circuit breaker. Use insulated tools and wear appropriate safety gear, such as safety glasses and gloves. If you are not comfortable working on electrical systems, do not hesitate to call a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. It is essential to consult with a qualified electrician for any electrical issues or concerns. Safety is always paramount when dealing with electrical systems.